Hey, what is going on everyone? I'm Wicked and today I should have been talking about some tips and tricks regarding BLoC library, but recently I have received some feedback from you and I decided that there are more important topics to cover prior to that. Guys and gals, today I will introduce you to block communication, especially how blocks or qubits communicate between each other. In this tutorial, we'll also cover up some further BLoC architecture tips and tricks and do a general recap of everything we learned so far, so that you'll be able to practice and structure your code even better. So without further ado, let's get right into it. But before that, make sure you check out the content overview for what we're going to cover up today and its specific timestamps. Also, if you want to follow up by practicing this tutorial, you need to clone my BLoC from Zero to Hero repository from GitHub and open up the 6th BLoC access folder, since that's where we left last time. Okay, so in order to start this lesson with a motivational purpose, you need to know that sooner or later, inside your application, you will have one or multiple blocks or qubits which may need to communicate with other blocks or qubits. By communication, I mean that one may do something in response to a state change of another. Remember from my third and second tutorial on this series that both qubits and blocks emit a stream of states. Well, because of that, other blocks can listen and receive those states and then act appropriately in response to them by perhaps adding an event or by calling a new function. So the main question here is, how can a block or qubit listen to another block or qubit? To be fair, there are two possible scenarios you can tackle in order to achieve this. Both have their own pros and cons and can be equally good, so the method you'll be choosing in the future will be strictly a matter of taste. Today, as an example, we'll learn how to communicate between two qubits by adapting our existing app a little bit, so that whenever the phone is connected to Wi-Fi, the counter will be incremented by 1. And whenever the phone is connected to mobile data, the counter will be decremented by 1. So we'll have an internet qubit and a counter qubit, both communicating one with another. Let's start by discussing the first method on how two blocks or qubits can communicate one with another. If you remember back in the tutorial number 2, when I talked about streams, I told you that in order to listen to a stream of data, you will need to subscribe to it by using a stream subscription. A stream subscription is the foundation object from which you can listen to a stream. So what would stop us from using it as a method to listen to a block or qubit? Well, nothing. So currently, we know that blocks or qubits start to emit states right after their unique instance is created. Most of them will emit an initial state right after they were created. So it's important to understand that the stream subscription object we'll use to listen to a block or qubit should be listening right from the start and actually before the first state is emitted. How can we do that? Well, by initializing the stream subscription inside the block or qubit constructor. So in our example, we'll set up an internet stream subscription object inside the counter qubits constructor, since this is where we'll start listening to the internet block's emitted states. However, you need to understand that since you created the stream subscription manually, you'll also need to close it manually somewhere, so that you won't listen to the stream forever. You can do this inside the overridden close method from inside any block or qubit. Okay, so we established the connection between the qubits. But what's the purpose of it? The purpose of it lies in the listen function. There you'll have a stream of internet states coming from the internet qubit. So since we want the counter incremented by 1, every time the phone is connected to Wi-Fi, all we need to do is checking if an incoming state is the one corresponding to when the phone is connected to Wi-Fi, and as a result, we'll count the counter qubits increment function right away. This is how you can use stream subscription in order to establish a block-to-block connection. Let's dive ourselves into the coding part. Okay, so after opening project number 6 inside VS Code, we'll start by browsing the pub.spec.yaml file. Here, we'll need to add the latest connectivity_plus dependency to our project. This dependency will help us find out when the phone is connected to either Wi-Fi, mobile, or to nothing. Note that on Android, if the plugin reports a Wi-Fi or mobile connection running on your phone, that doesn't mean it has internet connection. For now, we're only interested if the phone is connected to a network or not, and we don't care if that network sends or retrieves data from the internet. Now, let's start by creating our internet qubit and move it inside our qubit folder. The first thing I always code after creating a block or qubit are its states, because first and foremost you need to know the purpose of your block or qubit and also what are the possible cases it will return as a stream of data. So by analyzing the documentation of Connectivity Plus package, we can deduce that the first possible states are connected to Wi-Fi, connected to mobile, and disconnected. Since there are two almost identical states, we'll create an enum for the type of connection we're using. There are two types, so we'll have two members for the connection type enum, Wi-Fi and mobile. Now here's an architecture tip number 1. Predefined types, enums, constants, and generally code that doesn't change at all during the lifecycle of your app can be moved inside the constants folder. We'll create one inside the lib folder. We also need to create an enums.dart file, since every enum you'll create inside your app must lie down there for easier access. Therefore, the code will be more organized. Okay, coming back to our internet states. We have decided to have an internet connected and internet disconnected state. We'll focus on the internet connected for a moment. We know that our phone can be connected to the internet by using either Wi-Fi or mobile data. Therefore, the type of connection needs to be specified inside the state. This can be done by creating a final variable of the connection type. We'll assign it as a required parameter inside the constructor, so whenever the internet qubit will emit a new internet connected state, we'll have to mention the type of connection we're using, whether it's Wi-Fi or mobile. By default, every block or qubit comes with an initial state. This state is emitted when the block or qubit instance gets created. We know that we'll instantiate the internet qubit when the application starts, and since the plugin may take some time to detect whether the phone is connected to Wi-Fi or mobile or to nothing, we'll need to show a loading animation in order to let the user know that something is actually happening in the background. So instead of showing an internet initial state, we'll show an internet loading state. Now, if we switch to the internet qubit class, we can notice that when the internet qubit constructor gets called, the first emitted internet state down the stream will be internet loading. Okay, so we finished coding our internet states successfully. From this point, I like to continue by creating the specific qubit methods which will emit the states we created previously. The emit internet connected function will take a connection type as a parameter and will emit an internet connected state with the same connection type, so that we know whether it's the Wi-Fi or mobile data we're connected to. Last but not least, we'll create an emit internet disconnected function that will emit the internet disconnected state accordingly. So, to recap, the purpose of this internet qubit is to emit different internet connection states based on what is returned by the Connectivity Plus plugin. Therefore, somehow, we need to react to do something in response to the Connectivity Plus plugin. So we need to add a dependency of it into the internet qubit class. We can do this by creating a connectivity variable and passing it as a required parameter inside the constructor. Let's take a look again at how the plugin returns the type of connection of your phone. As you can see, it can either return it a single time when we call the check connectivity function, or multiple times through a stream that is internally managed by the plugin. We're really interested in the latter scenario since we always want to know the state of our connection. Hence, we want to listen to every possible connection type the plugin sends down the stream. How convenient! So today not only we'll learn how a block can listen to another block, but also how can a block listen to a specific stream of a plugin. Both have the same stream subscription approach, so it's amazing that we can tackle out both of them. Okay, since we need our internet qubit to listen to the Connectivity Plus stream, first and foremost, we'll need to create a stream subscription so that we'll be able to subscribe to the specific stream. Then, we'll need to initialize this connectivity stream subscription inside the constructor by subscribing to the onConnectivity change stream and then by listening to it. So, to recap, every time a new connection is noticed by the Connectivity Plus plugin, this onConnectivity change stream will send the connectivity result down the stream. Currently, our internet qubit is just listening to the connectivity results emitted by the plugin, but we also need to do something in response to them. We need to emit new internet states accordingly to what the connectivity result is. So every time a connectivity result is received down the stream, we'll verify if it's of type connectivity.wi-fi, mobile, or none. If it's of type connectivity.wi-fi, we will call the emit internet connected function from inside the qubit. In the mobile case, we'll change the connection type to mobile. And finally, if the connectivity result is of type connectivity_result.none, we'll emit the internet disconnected state. Note that we don't need to emit the internet loading state, since it will be automatically emitted when the internet qubit is created. If you hover on the connectivity stream subscription variable, you can see that Dart is warning you because the created Stream subscription hasn't been closed yet. We don't want it to be listening forever, so we'll close the subscription right when the block is closed. So let's have a little overview of what we did until now. So we added the connectivity plus dependency in our project. We created the internet qubit with its respective internet states. Inside the internet qubit, we created the methods from which we can emit our created internet states. And then we learned how a qubit can communicate with a plugin by subscribing to its stream of data. The stream contains the type of connection our phone records during the lifecycle of our app. Depending on whether the phone is connected to Wi-Fi, mobile, or to nothing, we called our qubit functions accordingly. Nice, we're really making a ton of progress. What's left for now is how our well-known counter qubit can communicate with the newly created internet qubit. Remember that our goal is that whenever the phone is connected to Wi-Fi, the counter should increment, and whenever the phone is connected to mobile, the counter should decrement. So let's switch our attention to the counter qubit. Since we need a counter to be incremented or decremented as a result of a new internet state, the counter qubit will be dependent on the internet qubit. So we'll need to have a final field of type internet qubit ready to be initialized inside the counter qubit constructor as a required field. Then, in order for the counter qubit to communicate with the internet qubit, we'll proceed as we did previously by creating a stream subscription which will subscribe to the internet qubit stream of states. Remember that each block or qubit has a stream of states you can subscribe to. Therefore, internet qubit has one too and will subscribe to it inside counter qubit, so that whenever a new internet state is retrieved down the stream, we can do something in response. In our case, we need to check whether the received internet state is a type of internet connected and the connection type is either Wi-Fi or mobile, so that we can call either the increment or decrement functions respectively. Again, we'll need to cancel the internet stream subscription inside the close method of the qubit, so that we won't listen to it forever. And now, here's architecture tip number 2. You have to agree that the code looks a little bit messy now, so let's refactor it a little bit. Inside the internet qubit, you can see that all we do in the constructor can be extracted to a method. We can call it monitor internet connection, since this is what the function actually does. We can do the same with the counter qubit. This time we'll call it monitor internet qubit, since according to the states emitted by it, we'll increment or decrement our counter value. All we need to do now is to provide both our internet qubit and counter qubit globally to our pages. But the reality is that the counter qubit is dependent on the internet qubit, and the internet qubit is also dependent on the connectivity plus plugin. So what do we do in this case? What I usually do is instantiate the objects by following the order from the least dependent one to the most dependent one. We know that our connectivity plugin doesn't depend on anything, so we'll create it firstly. And now, here's architecture tip number 3. A good practice when you want to create a standalone instance, which is an instance that doesn't depend on anything, is to create it at the top inside the main function and then inject it into the app, in our case within the myApp class. This way our dependent qubits, blocks or repositories can use their specific methods like block provider, repository provider to create and also inject themselves into the rest of the app accordingly, while also having access to the required dependencies. Of course, this varies on the way you chose to provide your blocks, as we learned in the previous tutorial. All you need to do is to adapt to your needs. Now, we need to modify the UI of the home screen a little bit. Just to double check that everything works, we'll also place a block builder which will rebuild a text widget accordingly to the current internet state. So whenever the internet state is internet connected, will display either Wi-Fi or mobile. Also, when the internet state is internet disconnected, will display a disconnected text widget on the screen. Finally, when the internet state is internet loading, we'll use a circular progress indicator to let the user know that some process is actually running in the background. We'll also disable the plus and minus buttons since we won't use their functionality anymore. I also did some refactoring to the UI code which only beautifies our app. You don't need to do that since we only care about the functionality right now. We can finally save and run the application, and as you can see, when it finds out that the phone is connected to Wi-Fi, a new internet connected state is emitted and the UI rebuilds accordingly. You can also notice that the counter qubit successfully retrieved the new internet state too, since it incremented the value by 1. And if we turn off the Wi-Fi and connect to mobile data, you'll see the same behavior. This time though, the counter will decrement. When no internet connection is available though, the application displays it properly and the counter doesn't do anything since it wasn't programmed to do anything as response to this state. We finally succeeded tackling up this block-to-block communication scenario by using StreamSubscriptions. I hope that from the above code you learned even more than that, since we also improved our block architecture structure even more. Let's have a minute and talk a little bit about the pros and cons of this StreamSubscription way of communicating between blocks. Well, for me, the advantage is that the code looks really understandable, readable, and easy to structure and maintain. This method will also help you practice your stream skills, since StreamSubscription is the foundation of subscribing and listening to the stream flow. A disadvantage may be that if you have lots and lots of block-to-block communications, you may be overwhelmed by the number of stream subscriptions you need to create. But most importantly, close. Things can get pretty cluttered in a big application and huge memory leaks may appear as a result. So if you're not really ready to manage the stream subscriptions, you'll need to take a look at the next method used to communicate between blocks and cubits. Remember that in my third Flutter block concepts tutorial of this series, I specifically introduced you to a widget called BlocListener. If you remember, this widget was meant to be used only when you want to do something in response to a block or qubit state change. For example, we used BlocListener to show an increment or decrement snack bar. So what prevents us from using the BlocListener in order to do something in response to a new state? Absolutely nothing. But why would we do that? What is the advantage of this over the stream subscription method? Well, the advantage is that you don't need to create a stream subscription anymore, since the block or qubit manages it internally from the start. So on having many blocks communicating with each other, you don't need to think of which subscription you should cancel or create. Everything is being taken care of under the hood. At the first glance, since the BlocListener is a widget and must be placed inside the widget tree, you may feel like doing something in response to a state change inside the UI introduces logic inside the UI, therefore violates our architectural principle of isolating the logic from the UI. This is wrong, because calling a new qubit function or adding a new block event isn't related to the logic of the app. It's just a notifier on what the block or qubit should do. It's just notifying the block what to do, not how to do it. Hence, by using the BlocListener widget in order to do something in response to a state change isn't related to logic. Okay, let's get into the coding part of this method. So definitely the most important advantage over stream subscription is the fact that we don't need to create or manage the stream subscriptions manually. So let's refactor the code and delete the subscriptions from inside the counter qubit. We don't even need the internet block dependency anymore, since we'll just listen to it by using BlocListener inside the widget tree. So the counter qubit class will actually be having just its plain functionality in there. But now, inside the home screen page, we can add a BlocListener somewhere here. Doesn't really matter where, as long as there is a context containing the block or qubit you want to react to the incoming states. So in our case, the context should contain both the internet qubit and counter qubit unique instances. We provided them globally, so they're available everywhere inside the app. I like to wrap the top of the widget tree of the page with the BlocListener so that it looks more organized. Remember that BlocListener is different to Block Builder. BlocListener just listens to a stream of data, while Block Builder listens and rebuilds the UI based on a stream of data. So it's safe to place BlocListener at the top of the tree, since it won't rebuild anything. So inside the BlocListener, we'll listen to the internet qubit and act accordingly by coding the behavior that we want. If the retrieved internet state is of type internet connected and the internet type is Wi-Fi, we'll call the increment function of the counter qubit. If it's of type mobile, we'll call the decrement one. Again, we can access the counter qubit unique provided instance by either calling context.block or provider.of. Now, if we save and run the project, you will see that the application has exactly the same functionality as with the stream subscription method. So what about the pros and cons of this BlocListener approach compared to the stream subscription one? Inside BlocListener, block library takes care internally of all its stream subscriptions, so you don't need to spend extra time verifying where they were created or closed in the first place. In the same time, adding BlocListeners inside your UI may also create some readability issues if you have a lot of them stacked one over another. So at the end of the day, it's up to you what's the method you'll be approaching more or less. Let me know in the comment section which one you actually prefer the most. This was the tutorial for today. I hope you like it. In the next tutorial, we'll dive more in depth inside the build context and more specifically how to tackle up the block provider that of context fails to find a block cubit error. Since I'm sure some of you aren't still aware of how the block context really works inside Flutter and particularly inside block library. In some cases, I was surprised too, so it's important to understand this build context key concept in detail. Until next time, if you enjoyed this tutorial, please like and subscribe to this channel. It really keeps me motivating doing these kind of videos. These tutorials really take a lot of time to make, so a share and a comment would really be appreciated. Thank you for watching, take care, see you soon, Wicked is out, bye bye.